Plastic from oil is strong but unsustainable. Ecoplastic is sustainable but weak. In today's episode, we talk about a research group from MIT building an open source tool that's like Hannah Montana. It helps us get the best of both worlds. What's up, everyone? On today's podcast, we're talking about a greener way to 3D print stronger stuff. And it's an awesome topic, talking about how we can get the best of both worlds from ecoplastic and virgin plastic. But before we jump too deep into that open source tool for 3D printing on getting the best of both worlds, let's talk about 3D printing in the fashion world. And this is a awesome technical resource from today's sponsor, Mouser Electronics. We like working with Mouser because not only are they one of the world's largest electronics distributors, they also are really, really well informed and really, really well connected with folks all around the world working on really cool things. And in this case, they're going to be talking about how fast fashion has negatively impacted the environment with significant volumes of wasted products. In this case, we've been able to introduce 3D printing into fashion to get like the attention of designers, movie sets, etc., to be able to build custom stuff that's unique without creating a ton of extra waste. And one of the awesome examples they included here is a designer, Danit Peleg, who was commissioned to create a 3D printed dress for one of the Olympic opening ceremonies. And this is just one example of how 3D printing has been used in fashion. And I actually got to collaborate on a pretty cool thing while I was working at Formlabs as an intern. We were 3D printing stuff for costume designers for movies. So there's an awesome crossover here between technology and art and fashion and Hollywood even. And in this case, even the Olympic ceremonies where designers can get ultimate customizability using 3D printing, and then also is able to deliver this custom style with a lot less waste.
It's one of my favorite intersections, art and engineering. Like, engineering is art to an extent, creating things out of nothing. But when they come together and, you, like you said, you get those incredible, intricate costumes in movies, shout out Iron Man. It's super exciting to see.
Yeah, awesome. So we're linking this technical resource in the show notes. It's an awesome primer on different ways that 3D printing technology is being used. Now we're going to bridge that to talk about the meat and potatoes of today's episode, which is an open source software tool from MIT called SustainaPrint that essentially helps us to get the Hannah Montana best of both worlds between brand new oil-based plastics, which are strong but bad for the environment, and then green or recycled plastics, which are better for the earth because we're reusing old plastic, but their mechanical properties aren't great and they break too easily. And this has created a challenge specifically in the realm of 3D printing, where if you want a really, really high performance 3D print, for the most part, the conventional advice is just go with the brand new oil-based plastic. Don't use the greener plastics that are better for the earth because they break far too easily. And this team from MIT is saying, hey, can we inform the printer so the 3D printer knows exactly where the print needs to be strong and exactly where you can actually compromise and use one of the green materials. And in this case, it's either a recycled material or a biodegradable material. They're weaker and they break more easily. But they basically tried to help inform the printer, if the printer can print with multiple materials, to print the parts that are critical, that need to be strong, using a brand new oil-based plastic. And then the other parts where you can relax a little bit and you don't need this this oil-based plastic, can we use some more of the biodegradable, eco-friendly materials there? So we're able to get a strong part that performs the way you want it to perform without using 100% oil-based plastics. You can also use these eco-friendly plastics as well.
I think it's a good moment to take a step back and talk about and understand why it is that these recycled plastics just aren't as strong as these virgin plastics, the oil-based ones. And what it boils down to is plastics are like these long polymer chains, right? And in order to recycle them, we typically shred them up and then do some sort of heat processing, like melting it down. And via that shredding process, you're chopping up all those polymer chains, therefore making the next product weaker. So every time you recycle it, it just constantly becomes weaker and weaker. And that poses a significant challenge for applications where strength or other mechanical properties are paramount, right? Like automobile applications, aerospace applications, they're never going to want second grade plastics. But
Yeah.
what these folks are attempting to address here is there a happy medium where we can, like you were saying, where we can leverage the virgin plastic in the points of a given product where strength is an absolute must, and then everywhere else we use alternatives. And the product that they came up with, I love the name of it. Have you haven't said it yet? SustainaPrint.
SustainaPrint? Yeah.
Yeah. Super. It just like addresses what it's about right off the bat. And it's this, software and hardware platform aimed at developing eco-friendly 3D prints. I don't want to steal the thunder away from the juice that you're about to spill, but I figured I'd give that little bit of context on, why these recycled plastics aren't as good as the virgin ones.
No, for sure. And there's, by nature of their, the way that those more eco-friendly materials are produced, right? It's from reclaimed materials, or it's from biodegradable materials.
Right.
They tend to be cheaper. So in this case, you get this awesome outcome where you're able to optimize not just for eco-friendliness, you're also potentially able to optimize for cost as well. And the way that this works is you kind of have to build a multi-layered software stack here. And so you need to look at the design. You need to understand where the critical areas are in this design. And the only way that you can get there quickly is by doing a simulation. So it simulates stress on your 3D model using finite element analysis, FEA, to basically find out which parts of your design are the most likely to fail. And those are the ones that will need extra strength. Then it marks those zones to be produced using strong plastic, and then it figures out how it can fill in the rest with the eco-friendly filament. And the best way that this works is on a 3D printer with a dual extruder. And what that means is there's two nozzles on the extruder. One nozzle is depositing this really, really strong plastic, and the other nozzle is depositing the eco-plastic. And they were able to get to about a ratio of 80% eco-plastic and 20% strong plastic, and they were still able to get 70% of full strength, as if they had printed the full thing using all the entire strong plastic. So imagine you're only using 20% strong plastic, but you still get 70% of the strength of it. And the way that they were able to do this is they tested different geometries with hooks and rings, and then they put them through mechanical tests, like ones that we did in mechanical testing labs in our undergrad,
Throwback.
pulling them, bending them, trying to understand how strong these are. And in some tests, the hybrid prints did better than the full plastic ones as well. So it's this awesome, like, multi-layered solution where first they're looking at the design, trying to understand where the critical areas are. How do they solve for those critical areas? It's by doing simulations with stress to figure out where they're most likely to break. They reinforce those areas with the strong plastic and then try and fill in eco-friendly filament the rest of the way where they can. And it's essentially like this mix and match algorithm that figures out where exactly you need to reinforce it, where exactly you can relax and use the eco-friendly filament, and then get a part that with even only 20% of the strong material, you get 70% of its full strength.
Now that one headline is already impressive, right? Using a fifth of the material, you're still getting 70% of the performance that you'd get as if you used 100% of the material. That's awesome. But what you mentioned afterwards is more interesting to me, where in some instances, the hybrid approach actually outperformed the fully virgin plastic approach. And the researchers noted is that in some of these experiments, especially with the stress testing, they believe this happened because the virgin material was far too rigid, it was too stiff, and the load could not be distributed as equally as the model could allow it to be. So now you have some material that is more forgiving, now optimized with this FEA analysis where only specific points have the virgin, that they're very stiff plastic. And now you're, leveraging the entirety of that structure to balance the load out, which I think is just really, really fascinating. And when I think about the world of 3D printing, these dual nozzle printers, as I understand them, have been really beneficial for printing something with material A and then using the other nozzle for material B, which is just a support that is going to be removed later on. At least me personally, I haven't heard about anything where they're trying to bring two different materials together for the purposes of mechanical strength. So that was really exciting. But I do want to put on my my critical hat for a second. The things that I'm concerned about would be like long-term usage, right? So you are doing this stress test, whatever, but I don't know how many cycles it takes to failure and how that differs from virgin material to hybrid material. The other bit is recycling. We want to be environmentally friendly, right? But now we're going from virgin plastic or PLA or whatever filament they're using to multiple types of materials together. And some plastics can be recycled and others can't. So how is that going to work for parts down the road? And then layer adhesion is probably my biggest one. How many materials can really bond well together? I'm assuming there's going to be different melting points, one probably higher than the other. So as you're starting to deposit these stiff layers, these virgin materials, how is that going to impact the longevity of the part overall? So just some thoughts. I figured I'd throw it out there.
No, I'm with you, man. And some other thoughts from my end. You went pros first, then cons last. I'm going to flip flop into cons first, then pros last. But
sounds good.
They've got this open source algorithm. It's pretty cool. The idea, I think, is that almost anyone who's got access to one of these printers could download the software and try it out. I don't think too many people actually have dual extruder printers at home. My guess is the vast majority of folks who actually have a 3D printer at home can't print multi-material. So that's like a little bit disappointing there. It's like, it would be cool if you could create like a phased printing algorithm where you could swap out materials on a single printer nozzle and then deposit materials in there. So it kind of limits let's say the total addressable market there is only folks that have dual extruder printers. Right now it only handles simple force setup. So my guess is, like you're saying for Bode, with durability life, looking at how this thing performs over several thousand cycles or several million cycles, that's not something that's supported right now. It's also probably not supporting tons of different forces coming from different directions. Right now it's more, you can kind of get it from the geometry of the parts that they have demonstrated on so far. Hooks, rings, pulling, bending. It's not looking at compound loads yet, I don't think. But that's areas for improvement. And when I look at the flip side, right, the possible ceiling here of my expectations, the future potential, I like the idea that it's free and open source. I like the idea that it uses less of the new oil-based plastic and keeps prints strong. But one of the things that's even more exciting for me, and you kind of alluded to it earlier, is this isn't just an eco-friendly model, or I even said it earlier, like maybe even a cost optimization model. This can be a mechanical performance optimization model as well. And I love the idea of being able to mix in eco-friendly filament where you can. But I also think about, can you mix in one filament that's more ductile than the other and another filament that's more rigid than the other? And regardless of sustainability impact or cost impact, can you get a new type of 3D printing performance that hasn't existed before by being able to combine multiple types of materials, simulate them? I think that this could have a lot more legs in the high performance realm as well, if you could understand that there were several different factors to optimize for. Say, help me pick two materials. I care this much about cost. I care this much about eco or sustainability impact, and I care this much about mechanical performance. Help me select the two materials for it, simulate it in FEA to tell me where I need to use material A versus where I need to use material B, and basically add another layer on top of this, which is like, tell me the performance requirements in advance. I'll help you select the two materials and then help you print them to achieve the outcomes that you want. I think that there's a lot more legs on this than just sustainable 3D printing. I think that this could be high performance 3D printing across the board, which is something that's exciting for me to think about as like an engineer who's designed stuff for 3D printing before, to be able to design for 3D printing with multiple materials in mind. That'd be really exciting.
I'm with you, man. Yeah, I'm excited about what they've done. And like you said, the open source nature of it, I think just opens the world a lot more in terms of what the future of this can look like. And selfishly, I'm most interested in that FEA nature of it and that dual material, whether or not it's sustainable, which kind of defeats the name of SustainaPrint. Mm-hmm. But that is, I think, something that would be really impactful to the field. So I'm looking forward to see what the open source community cooks up, or even academia, honestly, other researchers cook up in the coming years.
Exactly. The fact that they made the source or made the code open source that they can, other folks can test this out. I'm excited to see where this goes.
Absolutely. You want to wrap it up?
Yep. Most 3D prints use oil-based plastic, which is strong but bad for the planet. And greener plastics, alternatives that are biodegradable or recycled, they're better for the earth, but unfortunately they break far too easily. So a team from MIT developed this tool called SustainaPrint that mixes the two, and you get strong plastics only where parts might snap, and you get to use the green, biodegradable plastics everywhere else. So the result is you still get a tough print, but it's also eco-friendly, using less plastic. So basically, your printer could know exactly where to stay strong and where it can relax and stay green.
I love it. That's the
Thanks, dog. See ya.
Peace.